Okay, so this is a little Wi-Fi rover that I set up. I'm actually working on a bigger project, but I wanted to set this up to kind of work on the H-bridge and controlling the motors and the code in a small form so it doesn't run through a wall or something. So basically what this is it's got the ESP8266 module. This is the ESP12F. And right here is just a little USB to UART converter that I custom fabbed. And so this module is only about $2 to $3. All the components I used to build the USB to UART was only about $2 to $3. There's a couple passive components on here, just a few resistors, some capacitors, and a low dropout voltage converter. A lot of that stuff's just needed to program it with the USB to serial, but also this can be programmed now over the air. I have that in my code, so I could actually remove that entirely. Then over here I have a little module. I got this on eBay for about, I think it was like $3. I don't really remember now, but it wasn't that expensive. What this is, though, is it's a little lithium-ion battery charger. So that's used to charge the lithium-ion battery. But it also has a special function to where it'll step up the voltage for USB to 5 volt. So the lithium-ion battery's nominally 3.7. This will step it up to 5 volt. That'll give me a little more oomph on my motors, because at 3.7 volt they're just not very strong, and even at 5 volt they're not that strong. They're actually supposed to be quite a bit higher, but it'll work for what I'm doing. So I have some wires soldered to the underneath side of this USB port. There's actually little solder pads for the 5 volt. So that's all running over to this, which is a little H-bridge motor controller. This thing only costs about $3 or $4 on eBay, and 5 volt comes in. This actually has an LDO built onto it, step it down to 5 volt, and I could have bypassed that to go straight to my 3.3 volt LDO, but I didn't, because this power button here, you can see when I push it on, it powers the whole thing. That light comes on saying it's pulling current. So this just makes it convenient to use this, and that'll send, it's supposed to send 5 volt out, but the dropout voltage on that's a little higher, so it probably sends about 4 volt out. Anyway, so all this is pretty simple. The ESP8266 controls the H-bridge motors using pulse width modulation to move the motors forward and back. Now what I'm doing with the ESP8266 is I'm setting up a server that hosts a web app, and it also has WebSocket built in on port 81. So essentially what I can do is pull up on the phone the web app that's stored on the ESP8266, and the web app connects to the WebSocket server, so I can send data, the motor data from the app, to tell it what to do as far as moving the motors. And I can also send data from the ESP8266 to the web app, the host of the web app at least, to get information about battery and also Wi-Fi signal strength. So this is the little rover itself, and let's go take it for a test drive. Okay, before I take this for a spin, I kind of want to talk about the app. Right now I have it propped up so that the wheels won't actually go anywhere. I'll just go ahead and turn it on. And it takes it just a second to connect. I don't have an LED to tell me it's connected, but it doesn't take very long. Okay, over here I went ahead and got the app loaded up on an old iPhone. This also works on Android. It's cross-platform. So we just load that up, and this is the app. So there's a couple buttons on here. One of them I don't use anymore. I'm actually building this for a lawnmower, so you have a little button there to turn lawnmower on and off. And then we have a button called fast. So what this button does is it changes the max speed to a faster speed. So you can have small fine touches, or if you put it on fast, you'll get quicker touches. And this is instantly being transmitted over here. The other thing you can see on here, it's showing battery 100%. And then you can see the Wi-Fi signal. It's at 60%, 68%. And this is the actual signal of that ESP8266. And this data, the battery data, and the Wi-Fi signal is being transmitted about once a second through a WebSocket. So it works similar, basically like a little touchpad. When you touch it, you get a little joystick button. So when you move that forward, you can see the wheels start turning and you can move it around. You go different directions. So that's the app. It's pretty basic. You can put it on fast mode. Hold on. You can put it on fast mode and it'll go quite a bit faster. So let's go show you what it looks like when it's actually running on the ground. Okay, I got the little bot turned on, and then I just have to open up the app. And then I'll go ahead and put it on fast mode. It works a little better on fast mode. Just kind of show you how it works. And you actually have pretty good control over it. And you can reverse it. And then you can turn fast mode off and it just kind of moves a little slower for fine-tuned touches. But we'll put fast mode back on so you can kind of see what it can do. There's an algorithm on the joystick to control the motors. It took me a long time to write that. But essentially allows it where you can make a really smooth transition as you rotate around to the different degrees. But that's about it. And can spin in place either direction. And that's my little Wi-Fi web app controlled little Rover.